Hello, my name is Suyen Machado, and I'm the K-12 Data Science Education Director at the University of California, Los Angeles in the Department of Statistics and Data Science. I am also co-author of the Introduction to Data Science course and curriculum for high school students, or IDS for short. This is a curriculum that is being used in 121 districts across the United States and internationally. By now, we've all become aware of the prevalence of data in society. The ubiquitousness of data permeates all sectors, from industry to healthcare to education. So, what are the data related demands of the workforce? Well, according to the Harvard Business Review, 90% of business leaders cite data literacy as a key to company success, but only 25% of workers feel confident in their data skills. This statistic tells us that we have a lot of work to do to prepare our students to work with data. Before we get into how to prepare our students for this demand, let's take a look at some current data realities. Today, it would take a person approximately 181 million years to download all the data from the internet. However, since this statistic was created, the statistics have changed. It turns out that now it takes around 181.3 million years to download all the data. It turns out that 80 to 90% of the data we generate to date is unstructured. But what does that mean? It means that a user can contact a company through social media using a PC, surf the company website on mobile, make a purchase using a tablet, and contact customer service via email. As such, all data are generated from the same person, but it comes in different forms. Speaking of unstructured data, 95% of businesses cite the need to manage unstructured data as a problem for their business. Most of the data that we generate today, like in the other slide, it is unstructured, which means it comes in different forms, sizes, and even shapes. So it is difficult and costly to manage and analyze all these data. All of this means that this requires new skills from the workforce. And 96% of companies plan to hire job seekers with data skills. Most businesses no longer put data in the back burner as they now consider it a necessity. It's become an enormous factor capable of influencing smart decisions, especially when starting new projects. So, what does a person who works with data do? Well, typically they engage in a process similar to this one. In the first step, and actually prior to the first step, before collecting data, the person needs to understand what types of data are required. It is important to design the collection to avoid explicit or implicit bias. Sometimes the data has already been collected. It can be available from public repositories. The person needs to consider if the data that has already been collected will meet their needs. In the second step, the data are cleaned. The initial data sets or raw data usually have missing or incomplete information. Some of it may be repetitive, which can affect the conclusions. In fact, people who work with data say that between 70 and 80% of their time is spent cleaning data. Remember that unstructured data companies have to deal with? Well, unstructured data definitely needs to be cleaned and wrangled. The third step is to process and verify the data. Raw data is turned into usable form. In this step, the data is further processed to identify any errors or issues. Sometimes this is considered part of the data cleaning step. The data then goes through analysis. Different aspects of the data are examined. In this step, the statistical importance of the results is also checked. In the last step, the results are compiled into multiple forms to present the data in its simplest form and most understandable form as well. That's a lot. So how can K-12 education prepare students for this demand? We proposed a three-pronged approach in education. First, We must not ignore content. The data deluge has created a new skill set when working with data. Second, the way we teach must be emphasized. Student-centered pedagogy is important to motivate student learning and in learning how to work with data. Third, high-quality professional development is key to learn this new content and to leverage students' interest and achievement when working with data. Until recently, most curricula has focused on providing students data that is clean, conforms to the topic, and usually is in a data table, and it has a few variables. Students need to work with data in a more comprehensive way. Beyond inflexible data sets, they are small in size and comprising only a few variables. Students learn that data are messy, complex, and beyond numerical and categorical. Through a data lens, students learn that data can range from trivial and straightforward to meaningful and complex when data represent a cause they care deeply about. Students learn to see data as much more than numbers and also learn to consider text, images, sound, and video as data. These are the types of data students find relevant in their own lives and are therefore eager to analyze. For conducting data investigations, the statistical investigation cycle is an established framework identified in the Guidelines for Assessment and Instruction in Statistics Education 2, or GACE 2. This process places students in the driver's seat of their own learning. Undertaking an iterative process like the statistical investigation cycle allows students to engage in collaboration and discourse throughout their investigation, skills important in the workforce. In our high school curriculum, IDS, we propose the data cycle as a framework for conducting statistical investigations. We are interested in students posing questions, collecting or considering data, and analyzing the data to learn more about themselves and the world. For example, one issue our students investigate is about how they spend their time. Another focuses on their snacking habits, and a third helps them learn about stressors in their lives. Let's take a look at these 4 stages individually. In the first stage, students pose questions. Specifically, they pose statistical investigative questions. A statistical investigative question is simply a question that requires us to sort through data to answer. Why is this important? Because it motivates the data collection, the analysis of the data, and the interpretation of the data. In the next stage, consider data, students are collecting data through traditional methods or modern methods, such as participatory sensing. They also can examine previously collected data from national repositories or public repositories. They do this to determine the quality of the data for answering statistical questions or to assess the characteristics of the data in order to choose a statistical question to ask. And in cases where the data already has been collected, they need to see if it meets the needs of the investigation. In the next stage, analyze data, students create graphical representations and visualizations of the data that they're analyzing. They can also create numerical summaries to analyze the data. After that, they find patterns and relationship using these graphics and numerical summaries. Finally, in the last stage, interpret data, the statistical investigative question is answered by referring to the tables, graphs, and summaries made in the data analysis stage. We want students to interpret the analysis and generate knowledge and understanding. Remember the typical investigative data process shown earlier? Well, the data cycle is very similar, with one exception. The typical process is missing the data interpretation stage. Data interpretation refers to the process of using diverse analytical methods to review data and arrive at relevant conclusions. The interpretation of data helps researchers to categorize, manipulate, and summarize the information in order to answer critical questions. Students must learn to interpret data to answer those critical questions. When students pose their own questions, this learner-centered approach teaches them to become interrogators of the data. During the statistical investigation cycle, students are the question posers who can pose productive statistical investigation questions and then answer those questions with data. So how do you answer statistical investigation questions? Well, existing research emphasizes the importance of students' personal experience in the production of data. Data are ubiquitous in the lives of youth, and there are personal connections to data that must be considered to realize an effective form of data instruction. So how do our students become producers and not just consumers of data? One way to do this is through a method called participatory sensing. This is an approach to data collection in which students use their personal mobile devices to explore interesting aspects of their world. In the IDS course, for example, students engage in campaigns in which the personal data they collected informs them about their snacking patterns, about how they spend their time, and about their stress levels. As producers of these data, they can then analyze it. So how can these data be analyzed? Technology is essential in learning data science, and it's critical for implementing modern data analysis methods. Due to the vast amount of data collected and stored today, real-world data sets are hard to make sense of without the aid of a computer. GACE 2 aligns technological tools to the specific developmental levels of students. So for example, at the elementary level, students can explore basic single variable visualization with small data sets. The teacher can upload these data sets to a graphical user interface such as CodeApp and create the visualizations. At the middle school level, students may use a graphical user interface-driven tool, again, such as CodeApp, to create univariate or bivariate visualizations and search for patterns between variables. At the high school level, students can use code-driven data analysis software to understand the logic of inference and randomizing data production and conducting repeat simulations to create models of the world of chance, combining statistical and computational thinking. Some of these code-driven tools could be R, maybe through RStudio or Python. For all of these, the data can either be data they themselves collected or a data set from another source, such as publicly available government data sets. So it's not just students that need to feel comfortable with examining data more comprehensively, it's teachers as well. Engaging teachers in well-designed professional development to develop their ability to analyze and make sound judgments with data is crucial. Additionally, teachers need opportunities to learn to interpret and utilize methods and techniques that go beyond traditional statistics courses, such as scraping, bootstrapping, making decision trees, clustering, and simulation-based inference. Research has shown that continuous professional development increases teachers' pedagogical fluency, which in turn advances student learning. An important part of continuous professional development is sustaining teacher support. Teachers often plan in silos. New content lesson planning must be supported. For example, bringing teachers together to learn and plan, creating online support communities, or finding programs that offer sustained support on anything and everything, whether it be curriculum, technology, or content, are important to keep this ongoing support. K-12 education has been called upon to meet the demand of a data literate workforce. Working with data has the power to provide students with the statistical and computational tools to investigate topics that they are genuinely passionate about. This process begins with an empowered teacher who can unlock students' natural curiosity to explore the world through a data lens. Thank you. Hi, Lisa. I just got your message that you finally took a computer science class and now you know what I'm talking about. Thank you for sharing. From Kathy Haynes, how important or influential is for students to collect self-data versus already existing sets? Kate, I say both are important. Self-collected data, especially about something that students care about or pertains to their daily lives, is a great motivator. In our course that we created called Introduction to Data Science, it's for high school students. Students feel really motivated when they collect data and when they finally get to analyze it and learn some insights about their own habits and things that they're doing in everyday life. Is just keeps them motivated to keep learning. So, for example, there's one participatory sensing campaign, and that's just a fancy term for data collection that students engage in by collecting data through their phones or any mobile device. One of those campaigns is examining stressors in their lives. It's called a stress chill campaign. And so basically they're answering questions about at random times of the day about how they're feeling at that particular moment. Are they stressed or are they chilled? And then there are other questions about who are they with? What are they doing? Why are they doing what they're doing? And then they're really become really interested in learning, about how really stressed and how chilled are they, and what is causing them to react in certain ways. And then that's all great, but the best part about that is that they actually start to learn the statistics behind it. It's like, okay, why, let me do some analysis on some of this data. So that's why we really encourage that part. Additionally, research has shown that when students are the producers of data, there is a not just validation, but it also helps with relevancy. So that's important. The second part of your question has to do with already existing data sets. That's really important too, because there are some limitations to self-collected data. You cannot extrapolate to the whole population, and those are really important things for students to learn. Versus like professionally collected data sets. So you're learning skills even with the various analysis of the various data sets that are available. I hope that answered your question, Kate. Thanks for your follow-up question, Kate. Yes, we have an app that we created specifically for the Introduction to Data Science course. And the students do download the app to their phone. And when it's time to engage in that particular campaign, they collect data through that app. When we first started this course, it was back in 2014. And, students were starting to get cell phones, smartphones, right? That could have apps downloaded to it. One of the questions we get is like, do all students have access to the app? And yes, we haven't had any student who doesn't have a phone, and so they do collect the data through their app. If they don't, we have a web-based data collection web app as well. But yeah, that's how they do it. Hi, Lindsay. I couldn't agree with you more, Lindsay. Yes, data collecting is extremely engaging, very engaging for students. And what's what's really good about it is that they want to learn how to analyze the data. So those skills really start sticking to them. What does a mean? What is a median? And, so on from there. So it's engaging, and they finally feel like they have a reason to do the analysis. Okay, I'm reading Kate's comment right now. I teach stats at a community college, and we have students run surveys to collect data. Stress and study habits would be so interesting for the individual. Yes, Kate, I agree. Even for high school students, it is very, very interesting. And like I mentioned in the presentation, another campaign that the students do is called Food Habits, in which they're analyzing, they're entering information about the snacks that they eat based on the nutritional labels. And some students, find that they're consuming a lot more sweets than they thought, or, a lot more salty than they thought. And it's really cool to see their analysis. And then the third campaign that students engage in is called time use. In that campaign, students are collecting data about how they're using their time in a 24-hour period for about 5 days. And we use that campaign for students to understand how some of the data about time is collected. Because what we do after that, of course, students analyze their own data, but what we do after that is we compare that to the official data set from the Bureau of Labor Statistics survey called the American Time Use Survey. And anybody can go and get that data. It's publicly available. And so we have similar, we kind of modeled ours with theirs. And so now students get to, once they've analyzed their own data and seeing their own patterns and their own habits, then they say, hey, how do I compare to the rest of Americans? And so that's really, it's really motivational for them to say, okay, now here's an official data set. What can I learn and how do I compare? So keeping the students engaged and with the information that is relevant to them really helps in learning those skills. Lisa says, so exciting to hear about your authoring a textbook and having your CS program in so many schools. I remember when you were field testing your app around 2014 and going to visit. Oh, is that you, Lisa? Oh my God, Lisa. Hi, Lisa. Oh my God, I didn't put 2 and 2 together till now. Email me. So if I'm just wait time. I was just waiting to see if anyone else had a question. But I think one of the successes of our program is exactly that. Student engagement is very high, and all of the teachers that work with us go through a professional development. Yay! Thank you. I'm going to copy it. I'm copying your email address, Lisa. So I was saying the teachers who work with us, this past summer, we just trained about 100 teachers. And one of the things that they provide us feedback on is how much the curriculum is engaging to the students. And they feel that because of that, then students are eager to learn the statistics and also the coding, because the students in our course learn to analyze data using the R programming language, which is one of the programming languages that is an industry standard and used also in academic settings at the post-secondary level. If you want to learn more about our course, our professional development model, and our curriculum, you can actually download the curriculum. It's available for download. If you want to see the entire thing, you can go to introdatascience.org. and download it there. Oh, I see another question from Lisa. Would you tell us more about how you structure your professional learning for teacher? Yes, Lisa. So our professional development, it's actually over 2 years, and it's a big commitment. And believe it or not, our teachers always want more. For the first year, of professional development focuses on implementation of the curriculum. There's a lot of technology involved, so we train the teachers on the technology, and also on the curriculum and the pedagogy behind the curriculum. It is student-centered curriculum, like I mentioned in the presentation. So most of the teachers that we get are math teachers. So a lot of math teachers are not really comfortable with student-centered curriculum. And so we provide teachers in professional development the tools to carry that out in the classroom. In terms of logistics, teachers come to us for 9 days for the first year. They complete 5 of those days in the summer, typically 3 days in June or July, and then 2 days in August. And then they do 4 sessions throughout the year, 2 in the fall, 2 in the spring. The next year, the second year of professional development, they attend for 4 days, 2 in the fall, 2 in the spring. And the focus of the second year of the professional development is going deeper with the R programming language, building more on that pedagogical content knowledge, especially student-centered inquiry-based instruction. And then the third part is going deeper into concepts that we know are pretty difficult for students, pretty abstract, and just going deeper and working with teachers on those. Our professional development model that we use is based on the SIMPLE model, is SIMPL. If you look it up, it's called the SIMPLE model. And we modified it. So if you look up the SIMPLE model, basically what it is the teacher engages in the professional learning as students. And we're not asking teachers to pretend they're students. What that means is we ask teachers to engage as a learner. This is something that, you're learning maybe for the first time, and that has happened. So they engage as learners, and then at the end of each activity in which they engage as learners, then there is the reflective piece. And the reflective piece, they put on what we call their teacher hat. And in there, we ask teachers to reflect on the learning, to think about what might be some challenges when delivering that particular activity. What are some of the things that they really need to be prepared for? And so that is our professional development model. It doesn't matter if it's, year 1 or year 2, that is the model that we follow. So I hope that answered your question with enough detail, Lisa. So if you don't have any more questions, I would like to just say that we have a great opportunity here, in that our students will be going into a world of the unknown when it comes to AI, artificial intelligence. But if we really prepare them to work with data, artificial intelligence depends on data, right? It learns from data. So if we provide students these skills, as we saw in the presentation, there are a lot of jobs a lot of professional careers that depend on some level of being able to work with data. You have like your data scientists who need a PhD, right? And then you have the ones that um, do some, but at the lower level, just some simple data analytics. I'm just going to close by saying I met with a group from Mexico who was interested in our curriculum. And one of the things they said to me was, we really liked what you're doing, because it says we do not really need to show students how to work the robot, how to push buttons and work the robot. What we need are people who know how to read, interpret, and make sense of what that data that robot is putting out. That's what we need. And I think as we move more toward AI and different reports based on data, that's going to be needed. And we have a great opportunity here to have the students be prepared. Thank you.